of force will you feel? Attractive, repulsive? Which type of force will you feel? An attractive force. Attractive towards Q2 means what direction? Down and to the left. So force 2 will be directly towards charge 2, down and to the left.
For the second equation, do I need Q3 to Q8?
Oh, QA. I said it, but I wrote it wrong. Make sure you get it right. I wrote 2 for whatever reason, because I was being dumb. Strike that from the record. Thank you for catching that, Sydney. Now, I got some good news. If this is a square, and you're going from corner to corner in the square, we automatically know the angle that it's going to be. What is the angle? Theta, right here. It's a 45-degree angle, which means if that's a 45-degree angle, then the x and y components are going to be the same for my triangle. That force going down is going to have an x component and y component that are the same because it's at a 45-degree angle. That's super convenient. The equation we have to use, we're going to use the same equation, but we got to kind of fill in some blanks. F2. The magnitude of F2. I'm not worried about the direction. I got the direction here. I'm going to deal with that in a minute. I just want to know how big this line is, that F2 arrow. How big is it? Well, I'm going to use Coulomb's law. F2 equals K. We know K. Q2. We know Q2. QA. We know QA. Divided by the distance between them squared. I don't know the distance between them, but I can figure it out. I know this side is R, and I know this side is R. So what about this line bisecting the two corners? Can you figure that out?
Sine?
Not even that hard. We have two sides of the triangle. How do you get the third side of the triangle? It's the hypotenuse. How do you find the hypotenuse? The such and such theorem? Which? Yeah, Pythagorean theorem. So, no, it's not. This is a number, that's a number. You just plug them in. A squared plus B squared equals C squared. It's a square root of R squared plus R squared, or the square root of 2R squared. So R2 equals the square root of 2R squared. You know what R is. You just plug it in. You can get a number. Or you can put it into your equation just like that, which is what I'm going to do. So on the bottom here, we have the square root of 2R squared, and we square that. So the bottom of our equation there is just going to be 2R squared. Awesome. So what do we know? At this point, the physics is done. Isn't that awesome? We are finished with the physics. At this point, it's just math. And you guys are good at that part. So let's do the math. We know how big this arrow is, F1. We know how big this arrow is, F3. I need to know the components of this one before I can put them in, but I know how big the hypotenuse is. I know how big the arrow is. I just need to know how big the down part is and how big the left part is. And the down part and the left part are the same size. I can figure that out using a little bit of trigonometry. This is where your sine and cosine come in. F2 in the x is going to equal F2 in the y, because it's a 45-degree angle. And that's going to equal F2 times either the sine or the cosine. It's 45 degrees. Sine and cosine of 45 degrees both equal the same thing. So it doesn't matter which one you use. You can use sine or cosine. What do you prefer, sine or cosine? Cosine, all right. It's going to equal F2 times the cosine of 45. But they're down and to the left, and I've already determined up and to the right both being positive, so it's going to be in the negative direction. F2 in the x equals F2 in the y equals negative F2 cosine 45. Or F2 sine 45, they give you the exact same number. Good? We're in the home stretch. We're virtually done. F net, F total, in the x direction is going to equal F1, which is in the positive x direction, minus F2x, because it's in the negative direction. We're just adding the negative there. So we add them together, but since it's a negative sign, it's a subtract. F net in the y is going to equal F3 minus F2y. We're adding them together, but again, F2 and the y is a negative number, so it's a subtraction. I don't remember if the total is positive or negative, but we have two legs, and if it's like this, if this is F net x, and this is F net y, then the final answer, my final F net, is this, F net. And we can Pythagorean theorem to find it. We can use our trig functions to find the angle, and we're done. That's it. That was fun. That was fun. The old test that I posted had two more parts to this problem. The next part, well, first of all, does anybody have a question about what we just finished? It's a lot of steps. No single step in that process was difficult. As a whole, that's a lot of steps. The difficult part is keeping track of everything from step 1 to step 2 to step 3. If you can be organized and keep track of your steps, no one step on there was out of your ability, was beyond your capability. You are, every one of you in this room, capable of doing that process. It's just a lot of steps. Even Emily is capable of doing that process. The next question on the exam, the old exam, says, all right, you just calculated the force on QA. Calculate the electric field at point A. So take QA out. What is the field strength at that spot? And you could, if you were so inclined, go through the exact same process that we just did, calculating the electric field vectors, adding the components together, and finding the net electric field. It's a vector. It adds the same way. The process is identical, except you use the equation KQ over R squared instead of KQQ over R squared. And that would give you the correct answer. That would be a perfectly valid, reasonable way to do it. Except that would take a long time, and we only have about 7 minutes left of this class. So I'm going to do a little bit of physics magic. So if you are math-minded, you might do that same process again to get that answer. But if you're physics-minded, you might say, well, I know that electric field strength, E, is defined as force per unit charge. And I just found the force, the net force on QA. So I know the force on QA, and I know the charge of QA. If I plug those two numbers in, I can solve for the field strength there. I'll know the field at QA, at point A. How awesome is that? Instead of doing that whole process, once you have the force, you can use it to find the field.
My first homework thing, did you do that whole process though?
It made you do it in one. It made you do it on one line.
Yeah.
This is making you do it on two.
Yeah.
It's like probably when you did momentum, you would calculate the momentum of something, and I'm sure you had a problem where you had two cars crashing together, like at an intersection, and you had to put them together and find the net force at the end.
Yeah.
Right? It's the same thing. It's vector addition. It's no different. Momentum's a vector, force is a vector. If I'm pulling on this stool and you're pulling on the stool, it doesn't go your way and it doesn't go my way. It goes a combination of the two. Same deal. It's getting pushed by this, it's getting pulled by this, it's getting pushed by that. The tricky part is there's three, right? That's the hard part. I probably wouldn't give you three. It takes too long. I might give you two, and I might give you on an angle too. That's all something I'm allowed to do. Okay? All right, last one. And then I'll just take any questions from the audience until we run out of time. What if I gave you this exact same array and said calculate the electric potential at point A? V, electric potential equals V at point A. How would you do it? Electric potential, what kind of quantity is it? Vector or scalar? Scalar. So how would you find the electric potential due to those three charges at point A?
Now my mind here, could you technically, these equations K, Q over R, could you?
That's potential energy.
Oh, what is it?
Electric potential.
Oh.
If I ask you the electric potential energy at that spot, we would need to know what QA is, and we would do this pair, this pair, that pair, this pair, this pair, that pair, all of the different pairs, and you would add them up together. I'm not gonna make you do that, but you could. I just want to know the electric potential, also known as the voltage at point A. KQ over R, but I have three charges. How do I do that? You do them separately, then you add them up. I couldn't say it better, so I said it the same way you did. I find KQ over R for this, KQ over R for this, KQ over R for that, and I add them together. I do not care about direction because it's a scalar quantity. I do care about the positives and negatives, so you do have to keep them positive and negative, no absolute values this time. But I just do KQ over R for each one, add them together at the end. It goes way faster, which is why we like potentials. They're scalars, so it's easier. Again, that's a question I can ask you. Make sure you know how to do it. No, I haven't written it yet. I'm just letting you know. I did write about half of it, so I'm not quite done.
Is it gonna be like the quizzes where, because the practice exam has like no like multiple choice like type of conceptual.
Oh, really?
questions? I think, yeah, unless my comments are better, but.
Almost all my tests have at least some multiple choice conceptual stuff. But yeah, the test format never changes. I just fill it with different stuff. Other questions?
How is partial credit gonna be incorporated in?
All right, in general, I can't really give partial credit for the multiple choice because it's either right or it's wrong. Right? Like you can't kind of get it right unless I screw up the problem. But in the problems themselves, if you write down the given information, you get a point automatic. Usually I usually do like 10 of them. And they're worth like 6 points each, and the multiple choice worth 4 points each, so it's 40%, 60%. If you write down the givens and you write down the unknown, automatic point. Good for you. You're on your way. If you write down the appropriate equation, you get another point, just by default. So you're almost halfway there. If you fill in the numbers appropriately, I look for reasons to give you points. I give you half credit. If you've written down the givens, unknowns, and you've filled in the blanks, half credit right away, just automatic. At that point, the rest of the credit is that you put them in right and you get the right answer. So always write something. Leaving them blank is dumb because I'll give you credit. I try to find reasons to give you credit. I gave you, there's numbers in the problem, right? Like you can see them, they're right there written. Rewrite them underneath and then write down what it's asking for. That's a point automatically. And it's not real hard to get that point because you're just copy and paste from what I gave you into your own writing underneath. Did that answer it? Anything else about the test? What's your strategy for preparing?
Practice problems.
Where are you getting your practice problems?
For the exam.
Quiz, exam, those are good places. Where else? Homework, great place. Where else?
Organic chemist YouTube videos.
He's pretty good. He does okay. I did go out of my way to make sure that you had access to a free textbook, and it's full of solved problems. I mean, I don't know. Make it worth your while. Any other questions or comments or thoughts? All right, get out of here.
You want to see this kid on this show that looks